So here it has been told that from the point P, a perpendicular is drawn on the plane. One plane has been given from the point P. One perpendicular is drawn. So M is the foot of the perpendicular from the point P on the plane pi 1. And the equation of this plane pi 1 is given as just 2x plus y minus 2z plus 3, that is equal to 0. Um, and the point P, the coordinates is given as 1, 2, 4. And we have to find the equation, the length and coordinates of the foot of the perpendicular. So we need to find the equation of the perpendicular PM and the length PM, and also the coordinates of the point M. Coordinates of the point M. Okay, so let's say we can take suppose the coordinates of the point M is suppose x1, y1, z1. Then here it is, PM is perpendicular to the plane pi 1. So it means the PM vector, it is parallel to the normal vector to this plane, which is n1 vector. PM vector is parallel to the plane pi 1. No, sorry. PM vector is parallel to the normal vector n1 of the plane pi 1. So now the normal vector to the plane, which is n1 vector, that is obviously 2i cap plus j cap minus 2k cap. So therefore PM vector, that is equal to actually x1 minus 1 I cap plus y1 minus 2 j cap plus z1 minus 4k cap. And since PM vector is parallel to the n1 vector, so we can tell that PM vector, that is some lambda times n1 vector. So therefore we can tell PM vector, which is equal to x1 minus 1 I cap plus y1 minus 2 j cap plus z1 minus 4k cap, that will be equal to lambda into this n1, which is 2 I cap plus j cap minus 2k cap. So now if we compare both sides, then we will get x1 minus 1 equal to 2 lambda, x1 will be equal to 2 lambda plus 1, y1 minus 2 equal to lambda, then y1 will be equal to lambda plus 2, and z1 minus 4 equal to minus 2 lambda. So z1 will be equal to 4 minus 2 lambda. So therefore the coordinates of this point M, that will be 2 lambda plus 1 comma lambda plus 2, and this is 4 minus 2 lambda. So, and this point will satisfy the equation of the plane. Now the point M, which will have the coordinates 2 lambda plus 1 comma lambda plus 2 comma 4 minus 2 lambda, should satisfy the equation of the plane. Satisfy the equation of the plane since it lies on the plane. Since it lies on the plane. So now, therefore, we can say if we put these on the equation of the plane, we will get 2 into 2 lambda plus 1 plus y, which is lambda plus 2, minus 2z, which is 4 minus 2 lambda plus 3, that is equal to 0. Then if we solve it, then we'll get 4 lambda plus 2 plus lambda plus 2 minus 8 plus 4 lambda plus 3, that is equal to 0. So then we will get 4 lambda plus 4 lambda, that is 8 lambda, 8 lambda plus lambda, that is 9 lambda. So 9 lambda equals to 8 minus 3 minus 2 minus 2. So this is 7. So therefore lambda equals to 1 by 9. So therefore if we put lambda equal to 1 by 9 here, then we'll get the coordinates of the point M. Now therefore the coordinates of the point M, that is so 2 lambda plus 1. So first we need to find their values. So therefore 2 lambda plus 1, that will be 2 by 9 plus 1. So this is 11 by 9. And lambda plus 2, that is 1 by 9 plus 2. So that is 9 to the 18. So that is 19 by 9. And 4 minus 2 lambda. So that is 4 minus 2 by 9. So that is 4 9 is 36. So that is 34 by 9. Okay, so therefore the point M, that will be, that is given as 11 by 9, 11 by 9, comma 19 by 9, comma 34 by 9. Okay, so this is this M 11 by 9 comma 19 by 9 comma 34 by 9 is the foot of the required foot of the perpendicular from the point P, from the given point P on the plane. Then we need to find the equation also, equation of the foot of the perpendicular. So um, therefore the equation of PM will be r vector equals to a vector plus lambda into b1 vector, where b1 vector is nothing but the PM vector. That will be so b1 vector is proportional to PM vector. So therefore b1 vector we can take it as and b1 vector is, it is actually parallel to PM vector. So b1 vector is parallel to n1 vector also. So therefore b1 vector we can take it as 2 I cap plus j cap minus 2k cap. And a vector is the position vector of the point P, which is lying on this straight line which joins PM. So it will be I cap plus 2j cap plus 4k cap. Okay, so here, okay, so Here it is OP vector, which is this. Then so therefore the equation of the line PM, that will be A vector, which is I cap plus 2j cap plus 4k cap, plus it will be lambda times B1 vector, which is 2I cap plus j cap minus 2k cap. We can also write the equation of the perpendicular PM in the Cartesian form. Therefore, the equation of the perpendicular PM in the Cartesian form. Now, this is the required vector form of the equation of the perpendicular PM. So the equation of the perpendicular PM in the Cartesian form will be x minus 1 by 2, that is equals to y minus 2 by 1, that is equal to z minus 4 by minus 2. And the length of the perpendicular PM, that will be square root of so it is mod of PM vector actually. So PM vector is obviously lambda into the lambda value which we got, that is, so here we can take it as mu, since by lambda we have already taken it. This one we can take it as some mu we can take, since by lambda we have already used. So this is 2I cap plus j cap minus 2k cap, and lambda we have found it as 1 by 9. So it is equal to 1 by 9 into mod of 2I cap plus j cap minus 2k cap. So that will be equal to 1 by 9 into square root of 2 square plus 1 square plus 2 square. So that will be 1 by 9 into root over 4 plus 1, which is 9. So it is 1 by root 9 units. So this is the equation of the perpendicular PM. This is the length of the perpendicular PM. And this is the foot of the perpendicular PM from the point P on the given plane. So these are the final answers. Thank you.